Okay, so it's 9 a.m. in Minnesota in the U.S. We're gonna get started here today. It's a real honor for me to be here presenting to you on Snap Signal. So we're gonna be doing a webinar today covering Snap Signal technology, and we're gonna be talking about the products, some applications for Snap Signal, and we're going to be talking about doing a little bit of a Q&A at the end of the presentation as well. But before we get started, I'm just going to do a quick introduction. I'm Sean Foley. I'm a global product manager at Banner Engineering, managing a lot of the Snap Signal technology. And it's a real honor to be here. And then if Sarah, if you want to introduce yourself to the team, it's great to be here with everyone. But yeah, if you want to introduce yourself, Sarah.
Hello, Sean. Yes. Thank you very much for being present and for accepting our invitation for this webinar. It's an honor for us. My name is, I'm going to speak in Portuguese now, just for a little bit. O meu nome é Sara Tavares e trabalho no departamento de marketing da Bresimar Automação. Conosco aqui também nesta sessão temos o Sérgio Brandão, o nosso Product Manager da Banner aqui na Bresimar, e durante esta sessão ele estará disponível para responder às vossas questões através do chat aqui da plataforma. Portanto, estão à vontade para colocar alguma questão que entretanto surja e mesmo no final do webinar poderão contactar diretamente o Sérgio para o e-mail que nós vamos colocar agora também aqui no chat. Pronto, e da parte da Bresimar somos nós que estamos e o Sean e o Frederick vão agora então avançar com a apresentação do Snap Signal. Thank you, Sean.
Thank you. Thanks very much. Well, so everyone, I'm going to get started and talking about Snap Signal technology. And many of you may have heard of Snap Signal, but I want to go over it at a high level, talk a little bit about the products. So for the agenda today, what we're going to be talking about, we're going to be doing introductions, which we already did. We're going to be doing a product overview of Snap Signal. We're going to discuss some Snap Signal applications. We're going to talk about some demos that I have on the table here. And then last, we're going to have a Q&A session so you can answer any questions that you may have on Snap Signal. So Snap Signal, what is it? And I know there's a lot of stuff going on in this slide here. But what Snap Signal is, it's an IIoT enabling portfolio of hardware and software that allows you to gather data on your machines. So we've heard the word IIoT for quite some time. And what we did is with Snap Signal is we had a lot of customer conversations. Many end users throughout the world are using machines that have different protocols that talk different languages in terms of they may use Ethernet, they may use Profinet. And what we wanted to do is we wanted to have a way to gather data on those machines so they can make better data-driven decisions. And what's I'm going to walk you through this image here is that it's an overlay architecture for gathering machine data and sending that data to the cloud. And we're going to be talking about how it's brand agnostic and it allows you to add this technology to your existing equipment without disrupting your existing control system or PLC at all. So if we were to look at this data elevator, we call this the Snap Signal data elevator. You have all these different sensor types that may be installed throughout your machine. You may have a light, for example. You may have an analog sensor with a 4 to 20 milliamp output. You may have an IO-Link sensor installed on your machine. You may have a current transformer that's monitoring the current draw of a motor, for example. You may have a discrete sensor counting objects moving by. You may have a vibration and temperature sensor that's monitoring the vibration and temperature of your motors. With Snap Signal, what it's really all about is adding this technology over the top of your existing control system. So we're not disrupting your existing control system at all. And what we're doing is we're going to be taking in all these different signals, converting them over to a unified serial protocol, an RS-485 protocol. So they're all talking the same language. And we're going to be able to take it into our Dxm R90 Industrial Controller. And from our Dxm R90 Industrial Controller, which is about the size of my hand here, we're able to send that data out to the world. We could send that data to a PLC, we could send that data to a SCADA system, or we could send all this actionable machine data to the cloud. And so I'm going to be talking through this portfolio of products. We've got converters. These converters We have over 30 different varieties. They're about the size of a AA battery. So we have a converter that could convert a discrete signal to an RS-45 protocol, analog signal to a RS-45 protocol. We have converters that could take in thermistor signals. We have over 30 models of these converters available. And what's beautiful is Banner's a sensor company, but these converters are brand agnostic. You can take in any sensor signal type that has a 4 to 20 discrete output to fit the application. So we have a lot of really exciting technology here. We've seen a lot of success with it. So I'm going to talk about some of the benefits of this. Some of the key myths we've run into is people think that IIoT, it's this cutting edge, modern technology, and that it's only useful on brand new machine equipment. It can only be applied to brand new machine equipment. And what we found is actually the opposite. Most of IIoT's value comes from retrofitting existing machines, being able to add IIoT to existing equipment. In the United States, for example, the average age of manufacturing equipment is right around 20 years old, and it's been operating, it's working well, but it could be working even better by adding IIoT. So by adding IIoT, you could do things like improving downtimes, eliminating downtimes in a lot of cases, improving the overall efficiency of your machine. What we're going to be able to do is we're going to be able to, since this is an overlay, we're not going to be replacing or disturbing their existing control system at all. We're adding this technology on the top of that control system. It's an overlay architecture. And so what this allows us to do is allows us to install quickly. And it allows us to install this equipment with minimal risk. Since it's an overlay, we're not diving to their existing controls. And then SnapSignal will provide you all the hardware, software, and connectivity you need to get all this data, to act as the method for bringing that data to the cloud or your SCADA or your PLC. So let's talk a little bit about some of our converters. We have over 30 different models available for these converters, and they function simply. They convert one signal type to another. And we have models that convert discrete signals to Modbus RTU or to IO link, from analog to Modbus RTU and IO link, whether it's a 4 to 20 or a 0 to 10 volt signal. We have models such as this, where you have a current transformer. What are these? Where are these used? These are used, you basically clasp these around a cable that's going into your motor. And what that could do is you could essentially monitor continuously by clamping that around your cable. You can continuously monitor the current draw of your motor or other assets. And what we could do is you could take that signal, convert that over to an RS-45 protocol, and send that data to our controller, which I'm going to talk about in a little bit. But the key thing to emphasize is these are plug and play. You plug it directly into your sensor or anywhere in line for ease of use, and it converts these sensor signals. And we have over 30 different models available, more models than my slides can even keep up. So where can we use these types of devices? Let's talk, before discussing this further, let's talk about the Dxm R90 Industrial Controller. So after we've converted all these sensor signals to a unified serial protocol, we're going to be taking it into this device here. It's our Dxm R90 Industrial Controller, and as you can see, it's about the size of my hand. And this is a greatly capable device, because what's beautiful about that RS-45 protocol is that you could essentially take in, we've done testing where we're taking in over 100 devices into a single Dxm R90 Industrial Controller. So with RS-45 or Modbus RTU protocols serving as the method for gathering the data, you could do trunk and branch methods. So you could have a parallel wired M12T allowing you to bring in lots of sensor signals onto a single port of the Dxm R90. So let's talk some specifics. So the Dxm R90 has 4 Modbus master ports on the bottom. It has power on this port right here, and it also communicates Modbus RTU. And then lastly, so you provide power on this port, and lastly on this port here, it's a decode industrial Ethernet port, and that talks different languages. It talks Modbus TCP, Ethernet IP, and Profinet. So this is a greatly capable device for gathering lots of machine data in an overlay manner. So we're not doing control, we're just gathering data, and we're sending that data out to the world. We're sending that data either to a PLC, either to a SCADA system, or to the cloud, whether that's Banner's cloud data services, for example, which Banner has called Banner CDS, or you could send that data to something like AWS IoT Core, because this device has what's called MQTT. And I could talk about MQTT in a different presentation, but it's a way to send data to the cloud. And so here's an example where we're deploying on a conveyor the power of a discrete signal. So here we just have a discrete signal counting boxes. And what we're doing is we're simply using a parallel wired splitter, so we're not disturbing their existing controls at all. And this is what's really powerful. We could harvest sensor data that's already there with a parallel wired splitter. One branch is going back to your PLC. The other branch is going into a converter. And we're simply harvesting that data with an existing splitter, something as simple as a parallel wired splitter, connecting it to our Dxm R90 controller. And in this case, I set up a visualization element, so I'm going to be pushing this data to the cloud. And here we just, from this one sensor, we're able to get significant insights on this conveyor, and I'm going to show it in a little bit, but we're going to be pushing this data via HTTP push methods to the cloud. And here's something I set up in Banner CDS, just on that one discrete sensor signal. We could set up widgets to monitor the overall conveyor performance over time. We could see the throughput, how many parts per minute are moving past that one discrete sensor signal. What's the status of the machine? Are objects moving by? And from that one discrete sensor signal, we've seen a lot of successes with people making even things like personnel decisions. Sometimes if somebody's monitoring a conveyor, for example, and you're trying to track, well, one conveyor is working much better than another conveyor, you need that data to make those decisions and find out maybe there's something wrong with, maybe one person's efficiency is not very good. Or maybe the conveyor, there's something wrong with that conveyor that's consistently causing jams. From this actionable data, we could do a lot of interesting things. Another key thing to emphasize with this controller, here's an image of something we set up recently with an end user who wanted to put this as an overlay into their existing system. And essentially, they didn't want to disrupt their existing controls. And this is all part of the overlay. So what we did is we planned out the entire system, built out the connectivity for it, addressed the converters. So now we have all these different sensor signals going into one Dxm R90 controller. And from one Dxm R90, we're able to monitor a whole multi-million-dollar machine. And they're able to send that data to the cloud. So they're able, with these current transformers, I have another slide here, we're able to monitor the current drawn for their motors in their machine. We had over here on this setup here, we have one of these sensors, which is our QM30. This is mounted directly on a motor, and it monitors the vibration and temperature of the motor. So we're able to monitor those signals. We're able to monitor the temperature and humidity. With a thermistor signal, we're able to convert that over to a unified serial protocol and monitor the temperature of certain assets with a thermistor. So we're able to get actionable data with this overlay, and we're just able to put this over the top of their existing system and get really actionable data from it. So let's talk a little bit about IO-Link. I'm not sure how familiar you are with IO-Link, but Banner has IO-Link masters that allow you to take in any IO-Link sensor deployed globally and bring it into this architecture. Like I said before, the technology is brand agnostic. So most of Banner's converters, they could take in not just Banner sensor signals, but other sensor signals throughout the world. And that's a big benefit. So let's talk about some applications with these IO-Link masters. The ability to take in lots of IO-Link sensors into the IO-Link master is a real big benefit. So if you want to take in a Banner IO-Link sensor, you could do that. If you want to take in another manufacturer's IO-Link sensor, you could take it into this overlay system. So before I dive too deep into IO-Link, I could talk about IO-Link for a long period of time. Let's talk a little bit about some applications. So here's some applications where this technology can be used. So essentially, here we have two motors. We're monitoring those motors' vibration and temperature. We're taking it into a single port of the Dxm R90, but we also want to monitor the surface temperature of an object. Here we have a contactless temperature sensor, and we're able to just point that sensor at an object surface and continuously monitor the temperature of that surface and convert it over to that unified serial protocol. If you want to monitor something like tank level and you want to set up alerts in the cloud to get an email if the level falls below a certain threshold, or you want to continuously track the tank level in the cloud, you could certainly do that as well. So maybe if you have a tank and you want to monitor a 4 to 20 milliamp signal or sensor above that tank, you could monitor that. Let's talk about some more applications. Here's one where we're just monitoring continuously roll diameters. So here we have some analog sensors mounted above some rolls. And what we're able to do is we're able to tap into that sensor signal, take that 0 to 10 volt signal that's monitoring those roll diameters, that raw material, convert it over to a unified serial protocol, and bring it back to the Dxm R90 Industrial Controller. And from here, we're able to send that data to the cloud. A lot of cases, if your machine runs out of raw material, the machine is no longer producing revenue. So raw material tracking is something that's typically very, very important to track. And if you're able to set up in the cloud an email alert, alerting personnel that, hey, you know, your raw material, your roll diameter, or whatever raw material you're tracking is falling below a certain threshold, is a good thing to monitor and track. And what we're actually also able to do is add a visual factory element to this. And I'm going to talk about it with our demo here, but in addition to being, since this is an overlay, we're not disrupting their existing controls, we also have the ability through this Dxm R90 Industrial Controller to control lights. So if you wanted to add a visual factory element to this overlay, Snap Signal is an excellent method to do it because we're not disrupting the PLC, we're not disrupting the code. We're able to offer a fluctuating WLS15 light in addition to that cloud insight where you're tracking that data. We're able to add a visual factory element to improve the overall effectiveness of the application. Let's talk a little bit about some other applications, maybe pressure. You want to continuously monitor pressure of certain applications. A lot of pressure sensors will have a 4 to 20 milliamp output. There's many different manufacturers of pressure sensors that have a 0 to 10 volt output or a 4 to 20 milliamp output. We could convert that signal over. As you can see, there's the compact converter right here. It's about the size of a AA battery. And if you want to send that sensor signal already going back to your PLC, you could do that. But if you want to take that data and send that data to the cloud, you could tee off from that sensor signal so it's not disrupting the existing controls, bring it into a compact converter about the size of a AA battery, and send that data to the cloud. So the fact that it's brand agnostic is really powerful. Here's something where if you want to monitor the vibration and temperature of your motors, that's a big application. We saw a large success recently with an end user who deployed this solution, monitoring the vibration and temperature of multiple motors. And what they're able to do is by using that data and sending that data to the cloud, they're able to establish baselines for their performance on their motors. And with those baselines, they were able to detect anomalies. And essentially what they did is they found an anomaly with one of their motors and they were able to replace the motor. And they predicted that if that motor had failed, it would have caused 4+ hours of downtime. And in this particular end user, an automotive end user, that downtime, that 4 hours translates into hundreds of thousands of dollars. I believe the exact amount was $400,000 in downtime. So they're able to spot a failure before it happened in terms of predictive maintenance. Another thing is the R70 serial data radio. So I've showed a lot of wired applications, but what if you wanted to deploy technology where maybe the sensors are in a remote location and you don't want to use wire? Here are the R70 serial data radios that allow you to send data large distances across your factory. So maybe if you have a remote cluster of sensors, and these could be vibration sensors, these could be analog sensor signals, but what you could do, since it's RS-45, you convert them over to a unified protocol. You could send, with these R70 serial data radios, this data thousands of feet across your factory back to the Dxm R90 Industrial Controller. And so what's really unique about these R70 serial data radios is that they are have the ability to simply twist off the cover, set the dip switch settings, bind the radios, and you're done. They're really plug and play. And you could have large numbers of sensor signals connected to a single R70 serial data radio. So we had, for example, on that last slide, I showed just 4 vibration sensors, but you could have a mixture of different sensor signals going back to this R70 serial data radio. We've done testing where we had 50 devices connected to a single R70 data radio for a remote cluster of sensor signals. So a very powerful device. So now I talked a little bit about the IO-Link masters. Let's talk some applications. So here we have the ability to take in all sorts of sensor signals. So with our converters, you could take in things like temperature and humidity as part of the overlay. We could take in discrete, analog, RTD, thermistor signals from just about any type of manufacturer who develops these sensor signals. Bringing it in through a wire consolidation product, we could add vibration sensors, and we could send that data out via this decode industrial Ethernet cord set to a SCADA, to a PLC, or to the cloud. But with the R70 serial data radios offers another interesting element to it. So if you want to do both a combination of wired and wireless snap signal solutions, you could do that as well. So let's say you had wired going in, you have all these different sensor signals that you want to monitor, maybe a discrete sensor signal, maybe pressure, maybe temperature, maybe vibration, that you want to get actionable insights on your machine to get the better visibility into the health of your machine. But if maybe you had a sensor that's in a remote location, a difficult to reach location, you don't want to run that long cable length that's thousands of feet away up high in a difficult to reach location. You could have a remote cluster of sensor signals across your factory floor, bringing in lots of sensor signals in those difficult to reach locations. So it offers you the flexibility to combine both wired and wireless infrastructures to enable your condition monitoring and predictive maintenance efforts. And then lastly, the IO-Link masters are a greatly capable device. These come in a 2-port and 4-port variety. So they have 2 IO-Link ports and then a RS-45 communication, so it can connect directly to the Dxm R90 Industrial Controller. So this one, it's about the size of it's a 45 millimeter housing. This particular one is almost identical in size to the Dxm R90. It has 4 ports in the bottom. This one is a 45 millimeter housing, so it's half the size. So a very compact device. And on comms, it has an RS-45 protocol. So what this allows you to do is it allows you to take in any IO-Link device to this IO-Link master and connect it to the Dxm R90. So if you wanted to use it for control, you could use it for control. Or if you want to send this data to the cloud, so if you have your Dxm R90, you could pull in any IO-Link sensor and send that data to Banner CDS or AWS, for example. We're seeing a lot of the growth of IO-Link in terms of the number of IO-Link sensors deployed in the world. If you look at the IOLink.com, see the number of IO-Link nodes over the last 5 years, it's just been absolutely exponential. The number of IO-Link devices deployed, and the fact that we could pull in those IO-Link devices into this, the fact that it's brand agnostic in that regard, is really, really powerful. So you could find the correct device to fit your application. Another thing with benefit of this setup is with the RS-45 or Modbus RTU infrastructure acting as the method for gathering the data. You could have multiple IO-Link masters connected on a single branch going back to an individual port on the Dxm R90. So you could have large numbers of IO-Link devices connected. And really, the reason for this RS-45 protocol is it's a really robust method of gathering the data, because in the end, it doesn't really affect it, because we're essentially communicating Ethernet IP, Profinet, Modbus TCP, and on the method of gathering that, it's simply the method, the conduit that's a robust way of gathering the data. Again, with wireless, you could deploy wireless radios. If you have IO-Link devices across your factory floor and you want to send that data back wirelessly from your IO-Link device to this industrial controller, you could certainly do that as well. One application we worked on recently is they wanted to monitor with an IO-Link sensor clusters of IO-Link sensors deployed for tanks. So they wanted to take this IO-Link sensor, tank level in this case, connected to an IO-Link master, send that data back wirelessly to a Dxm R90 industrial controller so they could monitor that data in the cloud, for example. that's kind of some of the things we want to cover. I know before I end the webinar, and there's still a good chunk left, I want to talk about some of the hardware. So I've talked a little bit about the Dxm R90 Industrial Controller. It's a greatly capable device. So if you look at the device here, we have a decode industrial Ethernet port on the bottom, the way for sending that data out to the world. And we have 4 individual Modbus or master ports, so you could connect large numbers of data, large numbers of sensor signals to an individual port here. What's unique about this particular port is it allows you to daisy chain multiple Dxm R90s together. So you could send, you could have large numbers of Dxm R90s communicating with each other, or you could actually configure this to be a 5th master port. So you could have it functioning the same as these ports. And then on this decode industrial Ethernet port, it talks Modbus TCP, Ethernet IP, and Profinet. It also sends data via HTTP push methods to Banner CDS or to AWS IoT Core without any additional hardware needed. So here's a little demo highlighting some of the things we could do with this technology. So maybe if you have an analog sensor, for example, monitoring a tank level, and you want to harvest that sensor signal data. And here, maybe you're in a location where you want to monitor the temperature and humidity. This is a 4 to 20 milliamp signal, and this is a sensor that monitors the temperature and humidity of an environment. And what we're doing is we're teeing into those sensors and sending it back to our Dxm R90 Industrial Controller. So we have this sensor going in, converting that over to a unified serial protocol with this compact converter, about the size of a AA battery, and we're sending that data into this Dxm R90 Industrial Controller. So we're able to send that data out to the world on that decode industrial Ethernet port. And the fact that it's an overlay is really powerful. But like I said before, maybe on that roll diameter application, maybe you want to alert personnel if the tank level is falling below a certain threshold. In addition to sending that data out to a SCADA or to a cloud, you want to offer local indication as well. So without disturbing their existing PLC, we could set up with this WLS15 Lite, we could offer local indication as well as that data monitoring capability. So the ability with Banner's lighting products to improve the visual factory element. We've seen just great success with adding lighting products to improve the overall efficiency of these machines, to improve the overall equipment effectiveness. By adding something as simple as a light indication, you could alert personnel like, hey, you know, I got an email alert from the cloud that my tank level fell below a certain threshold, but I could also see on this light mounted directly on the tank that I'm running a little low. All done without disrupting the existing PLC, so we're not diving into their existing control system. Another thing is, if we have a temperature and humidity sensor here, we could add one of our lighting products. This is our K50 light. It has an LED display on it. So maybe if you want to send this temperature and humidity sensor data monitoring the environment out to the cloud, AWS or Banner CDS or whatever cloud platform you're using, and you want to send that data to there to monitor that over time to make better data-driven decisions, you could certainly do that. But if you want to also offer local indication to personnel throughout your factory that this is the temperature and humidity of the environment, you could connect this all as part of the overlay and see the temperature. And this, just so you know, it's in Fahrenheit, so it's not Celsius. So it's not otherwise I'd be melting, I think. So here's it's just showing and also on the outer ring here, we're able to program it. We set up a program that shows the humidity. So if I was to increase the temperature, you'd see that fluctuate here on this device, but you could also send that through the Dxm R90 Industrial Controller. We have a lot of different converters. Like I said before, there's so many. We have more than my slides could keep up. We have over 30 different models available, depending on the signal type you're using. We have devices that can convert over to that Modbus or RS-485 protocol to enable applications just like this or some of the applications I showed earlier. We've seen a lot in terms of successes with this technology. The numbers in terms of the successes we've had year over year with the converters were hundreds of percent. It's in terms of growth and numbers, so it's been really exponential. The number of converters that people are using year over year, as well as the Dxm R90 Industrial Controller, we're seeing a lot of growth with it. So we're really excited. Thank you so much, everyone, for joining. I know I'm going to leave plenty of time for questions. So is there any questions, Sarah, from in the chat or from people on Snap Signal technology?
Yeah, right now, no questions, but I can put one. Can you tell me more or less, do we have any limitations, number of slaves in each port RS485 in DXM? Since we can put several, yeah.
You could put large numbers. The limitation really with the number of devices you could connect on the Dxm R90, it's more to do on the power consumption. So if you have maybe devices, the only limitation I've really seen in a lot of these applications is the injecting power into that line of devices that you have connected. But we've done testing and verification with 200 devices, and it also depends on how much register data you're pulling from each device. So each of these converters has registers, and it stores data coming from the sensor. So if you're pulling maybe one register from the converter, you could have a lot of sensor signals being connected, 200 plus devices. But maybe if you're pulling like a vibration sensor, there's all this register data that you could pull, like X velocity, Z velocity. So if you're pulling 40 plus registers, maybe you want to use maybe 40 QM30s per Dxm R90 to be on the safe side. But we haven't seen too many issues on the number of devices. That's one of the big benefits of it. It really depends on power draw of the devices, and in that case, we have methods to inject power, and then also just the number of registers you're pulling. But for the most part, we haven't seen too many issues with that, with the installations of it. The fact that we can take in lots of sensor signals per port in the Dxm R90 is one of the big benefits of it, and excites a lot of our customers.
Yeah. Okay, thanks. I have here another one asking about the software. Which software do we need to configure this kind of solution of Snap Signal?
Yeah, we've got some two softwares. This is the one that would be the sensor configuration software. So in order to set this up, each converter has to have a device ID. In order to set up that device ID, you would need a tool called the sensor configuration software. It's a free software on Banner's website to set the ID for these converters. And so each converter, when it comes out of the box, is device ID 1. But if you want to set it device ID 2, you need to use that sensor configuration tool. In addition, for sending the data to the cloud and setting up the read rules for which data you want to pull from all these different sensors, you use something called the Dxm Configuration software. It allows you to set up the read rules. What data do I want to pull from all this converter? Because this converter could pull a lot of register data. It's all a matter of saying what data do I need to pull from that converter. And so that's the software you'd use for setting up that. It's the Dxm Configuration tool, and then for setting the IDs on these converters, it's called the Sensor Configuration software. And both of those are free on Banner's website. We also have a lot of tutorial videos available for kind of walking you through that process. One more thing to kind of highlight. So each port on this Dxm R90 Industrial Controller, they're independent networks. So you could have large numbers of converters connected on a single port, or devices connected on a single port. What's important to emphasize, though, is if you have out of the box, each converter is ID 1. But so you could have, since these are independent networks, device ID 1, you could plug in a converter into each of these ports. But if you have multiple converters plugged in on each of these ports, so maybe on port 1, for example, you have 5 converters. Each of those converters IDs has to be separate. It can't have the device ID 1 that it has out of the box. So you need to have a converter with device ID 1, device ID 2, device ID 3, however you want to do it. But other than that, you're essentially, that would be the way you'd avoid issues there. So.
Okay, Tell me other thing. When we are programming the Dxm by the software, can we program with other programming language like scripts or C++ or Python? Do we have flexibility to implement those kinds of more, difficult schemes to implement?
We do have the ability with MicroPython to do some really interesting things with the Dxm R90 Industrial Controller. I didn't cover some of those as much in this, but I could certainly send you all some information on how we could use those languages for doing some really unique things with this controller.
Okay, I have here another one regarding to the IO-Link. If we have an IO-Link network already implemented on the field, can we use this already implemented network to connect to our master?
So with IO-Links that they're using an existing IO-Link system, the ability of being able to take in an IO-Link sensor, in terms of the overlay, you'd be able to communicate with these IO-Link devices. But in terms of these IO-Link masters that we currently have are serial, so Modbus RTU. So it depends on kind of what IO-Link devices that they're using, but the ability to take an IO-Link masters from other manufacturers, we could do it as a part of the overlay. So we're not typically diving into their existing control system. And a lot of IO-Link applications that are already installed, they might already be communicating with the PLC already. So we can have a kind of discussion.
Maybe in these cases, it's better to to take the data from the sensor and not from the IO-Link hub that probably customer can have already implemented on the plant. It's better to go more on the sensor and put a splitter, and then the splitter go to our system.
Exactly, and sometimes it's the thing with the sensors is the question is which sensors do I monitor? How many sensors do I need to add to a machine to kind of get better insights into the overall performance of the machine and get that kind of actionable data? And some of the questions I like to ask is, what assets on your machine or on your manufacturing equipment, if they were to fail, would be catastrophic to your production? And do you monitor those assets continuously, or how do you monitor those assets? Is it something where people are going around with a clipboard and checking it on a gauge every few months? And then by kind of helping, like answering those questions, we're able to see, okay, maybe we need to add some sensors here. Maybe we need to harvest sensor signals with a splitter that may be already there, maybe a discrete sensor, or maybe we need to start adding some sensors to their machine as part of that overlay to get better insights into the efficiency of their machine and help eliminate, in a lot of cases, downtime, that could arise by detecting anomalies early before they fail. And even we're seeing things where people are using this data to optimize future machine designs as well. Data drives a lot of those decisions. Like a machine might be operating well, but by using data, we can make it operate even better by continuously monitoring certain assets or pain points on the machine.
Okay, I have another one here. Seems quite tricky. We know that we can implement Profinet and Modbus TCP and Ethernet IP by the Ethernet port with the Dxm. It's okay. They are asking if this communication by, for example, by Profinet is bidirectional. If we can get data from the PLC by Profinet and then send to the cloud by Modbus TCP.
It's an excellent question. I believe that does have the ability. I might have to check back with you on the capabilities there. That's a great question though. And then there's things too where there's a lot of methods for gathering data. So if you wanted to say, use this as a way as part of an overlay to gather data, and you want to send the data via Ethernet IP or Profinet to your PLC, there's a lot of PLC manufacturers there with Siemens and Rockwell. They have MQTT brokers already installed that allow you to pull the data from their PLC and send the data to the cloud. So there's a lot of methods that you could use for sending the data to where it needs to go with this. So a lot of flexibility with how you can pull data to the cloud.
Okay, thank you.
Yeah, you're welcome. Any other questions for me? It's been an absolute honor presenting to you all. And another quick thing before I let you go is there's a website or web page we put together that does a good job of covering all this technology. It's called snapsignal.bannerengineering.com. And so if you check out that web page, it'll have a SnapSignal brochure. It's about 32 pages, and it's great document. It's not super dry. It's very, very well put together with lots of application images showing the full portfolio of SnapSignal technology in terms of the converters, the connectivity and cables you need to pull the data, like what cable do I need to use, what splitters do I need to use, what T's do I need to use. It is all highlighted in that document. And that's on snapsignal.bannerengineering.com. It's a great resource for videos as well. So be sure to check that out. But is there any other questions for me on SnapSignal?
I have here another one that I am seeing now. Is there any plans to get this data through APIs?
APIs, there is that ability to do that. I could certainly follow up with you on the.
Yeah, not only focus on the Banner Cloud, but it's possible to try to integrate to other platforms outside.
There is. Yeah.
Okay.
With other cloud platforms, maybe if outside of AWS IoT Core, and you want to maybe send it to another cloud platform, for example, there are methods.
Okay. Thank you, John.
All right. Thank you so much, everyone, for joining me today, and feel free to reach out anytime if you have any questions. And thank you, Frederick and Sarah and everyone from the team for setting this up. It's been great presenting to you all today. And then feel free to reach out. I have a recording for this webinar that I'll provide, and then be sure to reach out anytime if you have any questions on this technology. Thank you very much.
Thank you, Sean, for all the information provided here. I'm sure it will be very useful for all our attendees. Thank you for your time and your kindness to show us how SnapSignal works. Well, now I'm going to close the webinar in Portuguese, if that's okay.
Absolutely.
Bem, então, se não há mais questões a colocar, vamos dar por encerrada esta sessão. Eu gostaria de agradecer a presença de todos os participantes e informar que qualquer questão que nos queiram colocar, basta contactarem-nos pelos meios de contacto habituais ou diretamente para o nosso Product Manager, o Sérgio. Já colocámos o e-mail dele no chat e ele com certeza que terá todo o gosto em vos ajudar. Convidamos também a visitar o site que o Sean falou há pouco, do SnapSignal, onde poderão encontrar mais informações acerca desta tecnologia da Banner. E pronto, e da nossa parte é tudo. Muito obrigada a todos por estarem presentes, por terem estado desse lado, e até uma próxima oportunidade. Muito obrigada a todos.
Thank you.
Thank you, John.
Thank you.
Thank you.
Bye, everybody.
Bye. Cheers.
Bye.